Hello and welcome to Re-enthused and part 4 of the sword repair and refurbishment. Yeah, we're not making a huge number of steps, I do accept that. It's taking quite a while just because there's very little documentation about the machine, and so yeah, we're kind of finding our way. But we are kind of at the position now where we can start to put this thing back together again. Obviously we already have started doing that with the previous episode, but also getting some of the casing back together and hopefully finding a solution for the power supply, which is what we're going to be doing now after a slightly less successful attempt last time. So let's get on with putting this thing back together again. Okay, so if you saw the previous video, there was a brief spell where you may have noticed that we sort of blew up the power supply we were going to use. Still don't know why. There was something touching that shouldn't have been touching, I presume. I still don't even know where that smoke came from either. It didn't pick it up on camera, which I was kind of hoping it would because I was going through the footage so I could work out what had happened, but it didn't. But it doesn't matter anyway. That power supply wasn't fit for purpose for what we needed anyhow. It didn't have a -12 line. It only had a -5 line. My fault for completely misreading what I needed. So I went about designing a new board, and this one, as you can probably see here, has an ATX header, which allows us to put this miniature ATX board in. Now what we can do with this is this gets powered with a 12-volt supply, so we will get a 12-volt supply that uses a UEC connector to power it, and then we'll just kind of feed the whole thing straight through. So it will eventually be powered using the UEC connector and switch from the actual sword itself, but just for now we can just power it straight from 12 volts. That's fine. So this is actually a much better way of doing it. My only problem with this these mini ATXs is would it have enough to power the everything on this sword, the drives and everything. It must be quite a power hungry machine given the amount of chips and stuff it uses, but it doesn't actually matter. We've got an ATX header on here. Worst case scenario, we can just put in an actual full-blown ATX power supply and it will work as well. So yeah, if I thought about that at the beginning, then I'd have just gone with that. As you can see, yeah, we've already applied the header in there and put the ATX board in. We have put the headers on and we put the fan control on. Now these holes I'll explain later. This board was not perfect, and this is kind of a good lesson to learn. When I was building this board up, I used a user-created ATX header, and as the instructions on EasyEDA say to you, always make sure you check those user creations because there's no guarantee they're correct. That's a bit of advice I did not take, and I just had the boards made, and it turned out that the header was almost completely wrong. That was fun. So, yeah, we've done lots of patching. You see, we've cut through the traces that were there, and we've just patched into them straight from the correct pins. So we can kind of test this now. We just need to get ourselves a 12-volt power supply. Plug it into here, and then we can just test the voltages at so we should have 12 volts here, -12 there, +12 there, +5 there, +12, +5, and grounds there. Should all be fine, but let's get a power supply just to check that. Right, so we have a very simple universal power supply plugged in, set to 12 volts. We'll just turn it on in a second, but first of all let's set up our multimeter. So we need it set to DC volts, which is this one here with the V with the straight lines above it rather than the curly lines. That's AC, and we just leave that as it is because we just need to get voltages. Now for this, even though this is ground up there, that's a mistake. Ground's over here, so we need to put our black, which we just dropped, our black probe that side, our red probe the other side, and that will be our first test point. I probably think if I can get there around the camera. Anyway, let's turn this on and see if anything goes pop. It does not. I really should have added a light to this circuit board so you know when it's powered on. Version 2. Right, so that's ground. Can we do this without There we go, we got a good 12 volts. Now let's check using these common headers. So that's, oh hello, we've got nothing there. Well, we've got nothing. Oh no, we just weren't touching properly. Come on, you can do it. There we are, 12 volts. And let's swap that over, and we have 5 volts. And over here, should have left them swapped really, never mind. We have 12 volts, and over here we have minus 12, close enough. And finally, we have, yep, plus 5 volts. Excellent. So those all add up. Let's turn this off quickly. Don't really want to leave a power supply running without any load on it. So that all adds up. Now, this turned on because we've done some bits to it. So an ATX power supply, the way it's designed is it's got a pin that's called PS on, which is basically a little pin which, when it's pulled low or to ground, it will tell the power supply that it's on and it should be powered up. Now, we're not really going to have that, so we've just bridged it. So if we look here, and I will zoom in so we can see it. Focus. You need a new camera really, this one's quite old. So we see right here, let's get a pointy thing so we can show you. So right there, we bridge these two. So this one here is the PS on, and that's a ground. So putting that low means it would always turn on. You can also apply a soft touch button onto it which pulls to ground as well. But if it's left floating or if it's high, then the power supply will not enable. Let's zoom back out. I'll probably have to zoom out a bit more than that, but we'll find out. So anyway, these holes. Let's talk about these holes. So we need to obviously mount this inside the case. And what we're going to do is we're going to, as we were before, reuse the existing power chassis. So that's this big boy. There we go. It's got a built-in fan. It's got these which we're going to be using, this big old switch and this power in. It's got a monitor out which we're not going to be using, but that's fine. This is the fan header, which we obviously created a header for right there. In fact, that's the one off the original board. And for the mounting, so this needs to be raised from the board. This is obviously metal and therefore conductive. And we have some pins which come a little way off the board, so we don't want those touching the metal because then we'll just have a whole ground going on. So what we've done here is, if we turn this to the side so it can be seen better, so we've got some just simple bolts going through, a nut to hold them on in the first place, another nut which is raised up so this can sit on it, and if we put this in place, so this goes, go on, you can make it. There we go. So that drops in. Possibly a bit lower on one end than the other, but that's not really a huge issue. And then we can put in more nuts on top to hold it in place. So it's a nice simple solution. Nice, fairly elegant, I'd say. I was actually trying to find plastic standoffs, but I couldn't find any. So this will do in a pinch. Maybe I'll get some to clean this board up at some point. I will do, because if I ever decide to sell this for some reason, I want this solution to be as reliable as possible. So our other option here, of course, is if this mini ATX doesn't work, there are a variety of slimline ATX boards, so we can always kind of find a way of packaging that together with this. That will probably work. Right. And I'll do this one. Now, we've tested the voltages. We're fairly certain that the correct voltages are going to go to the correct places. But we don't want to just immediately plug this in because who knows what will happen under load. Absolutely nothing possible, well, in theory, because this is a modern power supply and therefore they're usually fairly reliable and should do the same stuff regardless. But to be utterly certain, we just we'll power it up with just a little bit of load on, and we can do that because of this header and this fan. It's a 12 volt fan, so you know it's not nothing. It will certainly power up. So if we turn this to the side, or in fact, hey, let's turn it upside down. Nothing's going to be touching, right? Nope. There are some loose wires on here. So we'll just be a little bit careful. So this is the really dirty fan, which we'll have to clean out at some point. I've got to do loads of stuff outside, including finishing off the bottom of that case, which I will record. Unfortunately, the weather has been atrocious here, really poor. So we haven't really had time to go outside and do stuff. But anyway, let's turn this back on, and what should happen is that fan should start. Oh, there we go. Can you see that? Hopefully you could see that start. But yeah, it's pumping out a fair amount of air as well. Actually, it's pumping out a lot of air. That's really, really quite an efficient fan. It's also quite noisy, which probably says a lot. Well, quite noisy. I mean, it's old fan, it's dirty, so it's not so bad. Yes, anyway, that is working. So we know that the power supply is working. Under load, so that's good. So we just need to well, we need to connect it to the rest of the machine, and I guess we see if we get any kind of activity. There do seem to be lights on the board, so with any luck that will tell us what's going on. So anyway, turn you off. So I guess we go to the other bench and we start putting this thing together. Alright, so the first step then is to reconstruct the power supply. So this is obviously the part we've already put the R bit in, and then here's the side panel of that power supply. So we need to put the cables that connect to the main board onto here. But I think first of all what we'll do is we'll just verify, just to make sure we got the original power supply lined up correctly. Because the amount of mistakes we managed to make on this, it's always good just to be, you know, doubly careful. So we got then, we've got -12, +12, ground, +5. Seems right. Is that right? 1 pin, 2 pin, and then 3 pins, and then 3 pins. Okay, yep. And this one is these 2 pins. Then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 3. 3. 4 +5, ground +12. Alright, that seems to be the same. So, yeah, we're being doubly careful here because, you know, we want to try not to blow up this machine before we get the chance to do anything. So these are different sizes, so we can kind of work out without any issue which way they go. Plus they've got a keyed bit here which goes into the hook on that back part, so we can be fairly certain this one goes here, and we can get the holes lined up. There we go, and goes that way, so it can actually hook in. I think that's done. And then this second one is, I guess, the one that's running the drives. So that goes there. Is that hooked in? That's hooked in. Okay, so that's done. And then so we put those in first because they have to come through a hole. Out of the way, cable, right. They have to move out, go for a hole in here. So it would have been more difficult to put them in afterwards, as I found out when I was trying to take them apart. So this goes here, and then all of this feeds through this hole. So I'm doing this whilst reaching past my camera. So okay, so and then once all that's out, we can try to get this in position. It should fit. It fit before the other power supply, and that was a lot bigger than this board. Oh, hold on. I need this to come out of this hole as well, I think. Oh no, we just lost it. Where are you? Come back. This is the power lead for the ATX board. We need this to be outside as well. There we go. So, come on. You can do it. It's blocking this. It's just these cables. Because the cables aren't in the same place as they were. Okay, that's basically down, I think. Right, I'm not going to do it up because we still need to do more work on the power supply afterwards to get it to power from the back. But that should now be enough. We press that. Oh no, that is not going in on that side. That should be enough. Come on, you can go in. You can do this, come on. Maybe I can't, hold on. Let's stand up and do this. I need to go in there. There we are. Like it was from the factory. That is in place. I really need a lavalier mic to when I'm moving around. Right. Is this going to reach? It's not going to reach. Why is this not going to reach? That's an issue. That's not an issue I thought we'd have, I will admit. Because that's about the same place as it was in the other one. Ha! Alright, need to open this up again. Yep, after struggling to get it in all that time, we need to get inside it again. You know what, let's do it without the front case for now. We need to work out if we need to make some changes or not. And I think the answer is going to be we do. Yeah, because that barely reaches. Okay. I think the problem is, and the problem's solvable to a degree, so that this board in the original was kind of more close to the front, so there was a little bit more room. So yeah, that barely reaches, and I say that and it's still not actually in it. There we go, that's in now. Okay, that's a minor issue, but that's one we can solve at a later date. That's an annoying one actually. So this board, if it was further out, we would just have the space we needed. Well, possibly. Okay, we'll work it out anyway. Maybe this needs to be brought, or needs to be brought back more. These pins especially brought back here. Which we could do. That can move up there. These can come all the way back here. That might give us the room we need. Anyway, it's plugged in, that's fine. And then these go to the actual disk drives and the front LED. Don't have to worry about those just yet. Right. I mean, really, we should be trying to power this on. We've cleaned off this header down here. This was corroded, but it is much better now. That I don't think it matters which way. I guess it does matter which way it goes. Okay, we need to look at pictures to see, make sure we're getting it the right way. So we're back in a second. Okay, I'm pretty sure that's the correct way that it's supposed to go. Pretty sure. I guess we'll find out fairly quickly. Now the other issue is the lights that I knew was on here, the status lights, they're buried all the way back there, so that's going to be tricky to see. Yeah, I think even if I got a camera in there you wouldn't necessarily see that. Maybe we should try just to kind of put a camera looking down the throat of the thing. It's tempting to take these off again, although they were a pain to get on in the first place. But it is tempting. Anyway, well, let's see if I can reposition the camera to make it so we'll be able to see those status lights. Okay, so you can probably just see little green and red domes there. That's the lights, the status lights. So if we power this on, either something is going to blow up, or those lights will come on and tell us what's going on. We don't know what they mean, but we'll know something. Okay, well, there's no really more delaying. We just need to try and power this up, I guess. No idea, obviously. We've no idea if this even works to begin with, because it was marked as untested. It was obviously been stored somewhere for a long time, hence the corrosion. This may have been stored broken. I mean, it looks like it's in good shape, but who knows? We're relatively confident that the correct power is going to the correct places, which is really all you can be, all you can really do. Okay, let's power it up and let's just see what happens. Okay, so it's basically what we assumed. Well, not assumed, but what we were worried was going to happen. There's just too much load on that mini power supply to actually power this board. Actually, let's try it without it being plugged into the main board, just in case there's a some kind of grounding problem. No, it's okay. So yeah, I mean, I'm not smelling anything particularly awful, so it would suggest that there's just literally this board is trying to draw too much power for this micro ATX, mini ATX power supply to handle, which was always a potential issue. So what we're going to have to do then is we're going to have to buy a ATX power supply and see if we can find some elegant way of putting it into this system. One of them kind of slimline ones might just fit in there. We'll have to work it out. Maybe we can get it behind and then have the board out the front somehow. We'll have to work it out. But yeah. Unfortunately, then that's kind of it for this. But we are making progress at least. Something is powering up. Just a fan, admittedly, not hugely piece of amazing technology, but it's definitely turning on. We have a solution, although we do need to improve that solution quite a bit. And yeah, we still don't really know anything else about this machine. Well, this is an entirely new angle. Okay, so I mean, we are getting closer, although every episode we seem to be moving a little bit away from certain parts. But unless that's a short on the board, which is possible, we don't know again what state this board's in, then it's probably just that mini ATX just can't power it all, which was not unsurprising. There's a lot of chips on that board. There's a lot of voltages going through it. We did get the power light to come on and the fan to come on, so we know that at least there doesn't seem to be any short circuits in the cables, which is good. So next step, we need to find a replacement power supply that we can use. So we'll see if we can find any slimline ATX ones. I don't think I've got any. Maybe I do. I'll have to have a look around. I might have an ATX power supply kicking around somewhere from the super gun that I've got. So we might be able to try that out. But anyway, it is getting closer. Well, at least we're getting closer to having this thing buttoned back up and just trying it out. Which, yeah, we don't know how useful this machine is going to be yet. We've got no idea. It's not been powered up in a long time. It was not stored in the best of locations, but I've got high hopes. It does look like it's in good condition, internally at least. Yeah, almost there. Anyway, thanks for watching. If you enjoyed the video, please hit like. If you really enjoyed the video, please hit subscribe. If you didn't enjoy the video or you have something else to say, then please leave it in the comments below. Don't forget to hit the bell icon, and if you want to get early access to our videos, you can become a $1 or above patron. $1 is enough to get access to all of the content that's locked for patrons and to get early access to stuff. Don't like asking for money, but it does help fund stuff like this, which really just makes it happen faster rather than anything else. I'll do it eventually and record it and put it out. But if we get funded, it happens faster because we can get the stuff faster. But anyway, thanks for watching, and I will see you next time.